Well, hello. This video is going to be discussing some annuities. There's another video that I made previously that goes through these exact same problems, but using the calculator to go through and find them. This video is much shorter, and it's just going to show you how to use the TVM solver, either on your calculator or online, to solve many of these same problems. So I would encourage you to watch the other video first. This is more of a companion video, just kind of showing you some of the shortcuts. The other video goes into much more detailed explanations as to why I chose each type of annuity, whether it was a future or due, and I'll still hit on that a little bit, but the other video is just much more thorough. So in this one, you can see a flight operations manager is going to start a retirement savings plan where they're going to pay $100 per month. And notice that it is at the beginning of the month. And that's important because the beginning means that it's going to be a due annuity. And we want to know what the investment is after 25 years. So 25 years from now, that means it's a future value of a due annuity. Now our answer is going to come out to be this. And the other video shows you the long equation that you're going to use. But I'm also going to show you the shortcut, and that's what this video is. Like I said, it's more of a companion video. You can go to your calculator, and my calculator looks like this. It's a Casio. I know a lot of you guys have TI calculators, and you click on apps. I just don't have a TI emulator here to show you. But if you click on apps, then you can go to financial apps. Here on the Casio, you can see we actually have a button for TVM solver, and then we're going to be using compound interest. This is where this is going to ask you the number of payments that you have, the interest rate, and it's listed as like a whole number. So if it's 4%, you would actually use 4. If it was 4.5%, you would use 4.5. That's different than just plugging things into an equation. In an equation, 4.5% would be 0.045. Okay? Here we have present value. The payment that you're going to make, typically you will make your payment as a negative number, and you can think of that as because that's money that is leaving your possession to go someplace else. So we usually use that as negative. We have future value, and then the payments per year and the compoundings per year. So both the Casio and the TI have these. These should pretty well always match. Monthly will always be 12. And then what you'll do is you actually just go and put it on whichever one it is you want to solve for on the TI, and then you would have to hit the solve button, which would be down here. Here on this on the Casio one, you just click whichever one of these that you want to solve for. But I'm going to show you what I think is maybe even a little bit easier. So I have Google pulled up here, and if I just go to Google and I just type in TVM solver, it's like one of the first things that comes up. The very first one is here. I'll include a link somewhere in our site, I'm sure. But this TVM solver is just nice. So in this problem, you can see we're paying $100 at 5% interest at the beginning of the month for 25 years. So what we'll do is we're going to put numbers in for everything except the future value. That's what we want to know, so every other one of these blanks has to have a number in it. Present value, we're starting out with nothing. There's nothing in the account to start with. We're doing this for, let's see, $100 per month for 25 years. So $100 per month for 25 years, oh wait, sorry, payment. Payment is how much we're paying each month. So that's just 100. And I'm going to specifically put in negative 100 because that $100 is coming out of my pocket and going into this retirement fund. So I'm paying 100. We don't know the future value. The annual interest rate is just 5. The number of periods that we have, this is going to be 300. The reason it's 300 is because we have 25 years and then 12 months in a year. So 25 times 12 gets you 300 payments. And then we'll have this monthly. Now there's one other thing to watch out for, and that is we need to come over here and click the beginning because the problem says at the beginning of the month. Then we'll just hit future value, and that's where you can see that this is going to match up with our 59,000. So there's a whole lot less detail for this. Like some people are like, oh, that's cheating. Well, it's using the technology you have, but you still have to be smart enough to use it. I do like doing a couple with the formulas on the calculators, but ultimately this should save you time and hopefully will help you to, maybe even just know if you're doing it right. Okay, let's move on. Next problem. Phil purchased a new gazebo for his mother-in-law's backyard. The gazebo sold for $3,500, but he had to put a 20% down payment. He was going to finance the rest at 6.8% for 36 months. Find his new payment, or find his monthly payment, sorry. So because we're putting 20% down, you would take 3,500 times 20% is $700. That's how much you pay right now. That means you're borrowing 2,800. And we are looking for the present value of an ordinary annuity. It doesn't say that if we're making payments at the beginning or the end of the month, and so I just decided to use an ordinary annuity for this problem. And then everything else is just going to go straight into our TVM solver. It's going to look like this after you put that in there, and then you'll just hit this payment button right here. So you hit the payment button, and that will tell you how much your payment should be. So in this case, we'll put in 2,800 because that's the value of our loan. We don't know the payment, so I'll leave it blank. The reason I'm putting 0 in is because I want to pay the loan off completely. Our interest rate here is 6.8%. Remember, if you were using the calculator and you were going to use an equation, you would use 0.068. But because we're using a TVM solver, it's just 6.8 for 6.8%. And then lastly, this is 3 years, 12 months in a year. 3 times 12 is 36. We'll hit payment, and oh, I forgot one thing. Because I treated this as an ordinary annuity on this problem, it doesn't say, so I just used ordinary. And so I've got to make sure that an ordinary annuity is when you make your payment by the end of the month. So now we should be able to hit payment, and it will match that 8620, which is what we had up here. Okay, so you'll notice it says negative 8620 because that's my payment. That's what I'm paying out. Here's another one. It says Karen had a new bathroom installed. She financed the entire $4,900 at 2.8% for 36 months. What is her monthly payment? Okay, so let's go ahead. We'll go to the TVM solver again. Again, of course, you could do all this with your with calculator, but So I put all these numbers in. 4,900. We want it to be down to 0, 2.8%, so on. Click payment. You can see that you're going to owe 142.07. Okay, so that's that number. Now, if you do this in a calculator, it's going to give you this number here, which is more accurate, and it would then round to 142.07. Now, what happens, though, is Karen makes her 12 payments, and then she says, hey, I came into some money. I want to pay the whole thing off. So we want to know what's her payoff amount? How much would she write a check for so she doesn't owe anything else? What we have to first answer is how many more payments does she have? She's made 12 and she was going to do 36. That means she still has 24 payments left. Okay, so that's what we're going to use now is we're going to pretend like she's making 24 payments of this amount, and then what would that be worth? So ultimately, this is kind of what you're going to be putting into your TVM solver this time. And you can see I use this whole great big long decimal because it's the most accurate. And that's how we're going to end up getting 3312.13. Okay, our present value, that's what we want to know. We want to know how much is the loan worth right now if we're making these payments, and in 24 months we want to be down to 0. Now, if you use this 142.07, which is a little less accurate, but it's still very good, and I should have the tolerance set so that your homework should accept it. The tolerance is set so that it's like within plus or minus 1%, I think. So if you use this 142.07, we want to, there we go, and if we put in 24 months worth of payments like that, then that's how we end up getting that this will be $3,312.21. Basically, that means after 12 months time and you still have 24 payments left, this is how much you still owe on your loan. Okay, that's what that number means. All right. All right, let's keep going. I've got 3 more examples here that I'm just going to kind of show you the numbers that I put in, and then we'll take a look at them. A magazine editor starts a retirement savings plan and puts $340 per month deposited at the beginning of the month, right? And that's key because it's beginning of the month, into an account that earns 5.5% compounded monthly. So these are the numbers that we're interested in. Find the value after 30 years. Okay. Well, you can see that the answer comes out to be this: $312,051.76. But I did want to show you this, that if you put everything in correctly, you know, you're starting with 0, your payment is $340. This, of course, would be blank to start with. Interest rate, 30 times 12, 30 years, 12 months in a year, 30 times 12 is 360. You can see I have the exact same, everything is the same except what the future value comes out to be here, okay? And you can see as well that I didn't put a negative. I should have put a negative when I did these, but that's okay. Hopefully you guys realize that, well, if you don't put a negative here, you just end up with it there. But okay, so the difference is here we made the payment at the end of the month, and here we made our payment due at the beginning of the month. And this problem specifically says beginning, so you have to make sure that you do select beginning, and then that will get you this for the answer, $312,051.76. But by making your payment at the beginning of the month, you actually end up having not quite $2,000, about $1,500 more. And I kind of talk about that in the other video, like what the difference between that is. Okay, but those are where the numbers would come from. Here, a xylophonist for an orchestra deposits $240 at the beginning of each month into a Roth IRA. The other video I do talk about this. Definitely you want to have a Roth IRA. It's a great tax advantage savings plan. You should set one up. The IRA has an annual interest rate of 2.4%, compounded monthly. Find the value after 20 years. So that means we're looking at a future value, okay? And this time, because it says beginning of the month, this is what we would call a due annuity. But you can also just select beginning if you're going to use TVM Solver. Here's the numbers you put in. Here's what you would end up with after you click this future value button. You just touch that button and bam, it solves it for you. Man, that's easy. Jim and Pam. My wife loves The Office, so I had to throw this in there. They wanted to save some money for their daughter, Cece. She's going to college. So they want to have $100,000 in 18 years. They decide to put back $600 at the end of each quarter. Notice this time it says quarter and not monthly. And it is end, which means it's ordinary, not due. So the first thing you want to do is make sure you collect on end. And then it's 7% compounded quarterly. So will they have enough? Well, rather than going through and seeing if they end up with at exactly 1,000, which is one thing that we could do, let's see how much they would have if they saved $600. If you save $600, you put your numbers in like this. Notice that you have to change compounding over to quarterly. Your periods, if you can't see that, it says 72 here. The reason that's 72 is because it's 18 years times 4, because they're doing it each quarter. That's why there's 72 here. And they end up, if they go with this amount, they would actually only end up with $85,000. So they're coming up short this way. Another way that you could have done this problem is you could have put a future value of 100 here and solved for your payment. And had you done it that way, you would have found that your payment comes out to be more than $600. Let's just do that real quick. If you put those numbers in, they're starting with 0. They want to have $100,000 saved, and they want to do that at 7% interest for 72 periods, compounded quarterly at the end of each month. When you click on this, you find out that they would actually have to pay almost $700 per quarter, $703.60. So if they were to pay $700 per quarter, then they could get to 100,000. But because they're only paying $600 per quarter, they don't end up quite what they wanted to. So I hope this video helps. I know this was very quick. The other video is much more thorough, so make sure you check that out if you need that. I would encourage you to watch that first. This is just showing you how the TVM solver works.